Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve LQ question number 278, first bird version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all versions after a bird version are also bird. Okay, suppose you have n versions 1 to n and you want to find out the first bird one which cause all the following ones to be bad. You are given an API bool is bad version which returns whether version is bad or not. Okay, implement a function to find the first bad version. You should minimize the call of the API. Okay, they have given this clues. So let us see an example. See here. Let us take this is the versions, and there are totally 5 versions totally. Let's all take. So this is version 1, this is version 2, this is version 3, this is version 4, and this is version 5. Now observe carefully where's the word version occurs at first. It occurs at this point. So my output should be what? 4. Okay, so this is what the problem statement states, but they don't directly give this array, but still we can find by iterating to each and every one element, right? Just observe here. The first approach, that is easy approach, is iterate from 1 2 3 4 and 5 for this question. Okay, now check whether this one is a bad version, whether this 2 is a bad version. Just see, this one is bad version, it is good, no. Then whether this 2 is bad, no, it is good. Whether this 3 is bad, no, it is good. Whether this 4 is bad, yes, it is bad, it is bad. So we want to return what? We want to return 4. That's all. That's all about the code, right? So this is what the first approach. So what is the time complexity? I can say the time complexity is O of L, because we are traversing through each and every elements, right? And then what is the square? What is the space complexity? It is O of 1, because we haven't used any auxiliary space, right? Now, what is the second approach? How can we optimize it? Okay. All good version are at one group. All bad version are at another group. Why can't we use a binary search approach? Why can't we use this? Okay, how do we use this in this list? Okay, let's take uh 1 2 3 4 5. Okay, now what is the lower limit? It is here. What is the upper limit? Here. Now what is the mid? Here. Okay, mid is 3. Whether 3 is good or bad? 3 is good, right? 3 is good. Okay, it is good. Then this all will be good, right? This all will be good. So checking in left is waste of time, right? So I can check in right. So I will go to right. So now this is my low, this is my high. Now here is my mid. Now I'm going to check whether this 4 is good or bad. It is bad. It is bad. So it may be my answer. It may be my answer. So I will put it at 4 in my answer. In my answer. And I'm going to check whether any bad version before this 4. Before this 4. So I will shift this low, this upper pointer back here. Mid minus 1. Now upper pointer is less than the lower pointer. So I should stop here. I should stop here. So what is my answer? My answer is 4. So what are the two steps we have done here? If the mid value is true, okay, that is it is bad version. If it is bad version, what we have done? We have done like we inserted into my answer, inserted it into my answer. Then also we just moved our upper limit mid minus 1. Okay, this is my first observation. Now what is second observation? It is mid value is what? Good. It's good. Then we can ignore these all left values and move our left pointer to right side. So these are the two simple steps, right? These are two simple steps. Just apply it. Okay, now what is the time complexity? It is O of log n base 2. Simple binary search. Okay, now what is space complexity? It is O of 1. Fine, let us see the code. Just a second. Yes, L comma u is equal to 1 comma n. Now answer is equal to n. While L is less than or equal to u, mid is equal to L plus u minus L divided by 2. Just I am finding the mid pointer. Then is bad version of mid. If it is true, then what should I do? It can be my part of my answer, and also u is equal to mid minus 1. I want to check whether there is any bad version before the current midpoint, right? So I am moving the upper limit towards the left side. Now else I want to move my lower limit towards the right side. That's all about the code, right? Then at last I am returning the answer. That's all. So simple, right? So this question is a little bit complicated, but still, if you understand the question clearly, you can solve it in using the binary search approach. Thank you.